So this video lesson talks about two things. First, it is an introduction to negative numbers and what negative numbers mean, and second, it is a discussion of what's called absolute value. And to first start talking about negative numbers, we're going to look at something that we're all familiar with, and that's the idea of temperature. And to talk about temperature, we're going to talk about thermometers. And we're not talking about digital thermometers that just give you a reading much like a digital clock is compared to a regular analog clock. We're talking about thermometers that have some sort of liquid in a bulb, which used to be mercury but isn't anymore, that as the temperature rises, the liquid rises up the tube, and as the temperature drops, the liquid falls down the tube. And the reason we're going to use that is because thermometers have markings, and at some point on the thermometer, we're going to see a marking of 0. Now we know that 0 isn't the lowest temperature we can have in Fahrenheit or in Celsius. There is a temperature scale called Kelvin where 0 is the lowest, but you're not going to learn about that until you get into high school science. But in our Fahrenheit scale, 0 is by far not the lowest temperature that we've talked about. We've had lots of times in the last few winters where the wind chill has been either below 0, the temperature at night has been below 0, and even a few years ago where the temperature during the day didn't really reach above 0. So on the thermometer, we said that the liquid will rise as the temperature increases. And the temperature increase actually causes that liquid to rise. So above 0 on our temperature thermometer, we'll have things like 10, 20, 30, 40 degrees, etc. And in between each of those sets of 10 degrees, we would have little marks that represent individual degrees, but we'd also have those half marks that mean 5, 15, 25, etc. So as we go up the thermometer from 0, we're counting the way that we're familiar with, which is with positive numbers, and we know how positive numbers operate. But, as we said, the temperature doesn't stop at 0. It starts to go down into the negative numbers. And with those negative numbers, we think about them as counting down the degrees below 0. So if we have 5 degrees below 0, we call it negative 5. And that's 5 degrees away from 0. If we are 10 degrees below 0, we call it negative 10. And that's a difference of 10 degrees between negative 10 and 0, except the negative 10 degrees is actually colder than 0. And on and on and on and on. And we could keep filling in the thermometer with negative 15, negative 20, etc. And thinking about a thermometer like this, where we have 0 as a sort of central point, and as the temperature becomes greater, we count as we do with positive numbers. And as the temperature drops below 0, we almost count backwards. In the same way as positive numbers, except in negative numbers, getting lower and lower and lower, is how we think about positive and negative numbers on a number line. Because the positive numbers are the ones that we're familiar with, counting up 1, 2, 3, 4, 5, etc. Whereas the negative numbers, the ones that we're not entirely familiar with now, we're counting the same way, but backwards. Negative 1, negative 2, negative 3, negative 4, negative 5. Always naming these numbers after the steps we have to take from 0 to get to them. Like 3 is 3 steps from 0. Negative 3 is negative 3 steps from 0 too. And the reason we chose a thermometer is because a thermometer is basically a number line on its side. So using the idea of the thermometer, we can take some numbers, some positive and negative numbers, and we can order them from least to greatest. And what we have to remember about this is that starting from our central 0 point, we know how to order positive numbers. But take a look at how the negative numbers work. So go ahead, pause the video, and see if you can order these numbers from least to greatest. The numbers right on the screen, everywhere from 12 and negative 8 down through 9 and 11. So pause the video and come back when you are ready to move on. So we have a bunch of positive numbers here that are easy to order. We have the 9, the 11, the 12, and the 18. And we also have 0. The difficult part of this potentially is negative numbers. And if we look back at that number line and we think of least to greatest from left to right, we see that as our negative numbers seem to get bigger, negative 8, negative 10, negative 12, negative 16, we're actually getting farther and farther to the left, and that is farther and farther away from 0. So the greater the apparent value of our negative number, and we're going to change that phrase in just a second, but the greater our negative number seems to be, it is actually lesser, because very large-looking negative numbers have lesser values than very small-looking negative numbers. So in this case, the least number is actually the negative number that looks the greatest, or that would be the greatest when it's positive, and that's negative 12, followed by negative 9, negative 8, and negative 5. And we can see that by looking at a thermometer or a number line. Negative 12 is the coldest of these temperatures, followed by negative 9, negative 8, and negative 5. And that's how we can think about that. After that is 0, because 0 is the transition from positives to negatives. And then finally we have our good old familiar 9, 11, 12, and 18 in the ordering of positive numbers. So again, it's important to remember that when we're ordering negative numbers and we're ordering positive numbers, that we can think about them like temperature. The least temperatures are the greatest looking negative numbers. And because it's been really awkward, as you've heard, for me to try to talk about a big looking negative number without calling it a big negative number, because negative numbers are not big looking negative numbers aren't greater than small looking negative numbers, we need to find a way of talking about that. And there is actually a phrase for talking about the size of a number, size in quotes, when it's positive or negative. And so to think about that, we have to look at the number line and see if we notice any patterns with the positives and the negative numbers. So pause the video for a second, sketch down some thoughts. What do you notice about the positive and negative values of the same number value? So 1 and negative 1, 5 and negative 5, etc. Well, one thing you might notice is that 1 and negative 1 are both the closest numbers as far as integers are concerned, integers being whole numbers, positive, negative, or 0, from 0. And then 2 and negative 2 are the next closest, and they seem to be at the same distance away. 3 and negative 3 follow that same idea. And it's almost like you could put a mirror down the center of a number line, and the 1 and negative 1 are the same distance away from the mirror. And 2 is looking at its reflection, negative 2, in the mirror on either side of 0, and they're the same distance away. And the same with 3 and 4 and 5. And so this idea of distance from 0 is how we talk about the size of a negative number compared to which number is the least and which number is the greatest. And the distance away from 0 is something that we call absolute value. So go ahead and pause the video and write down this definition right here of absolute value in your notebook. So when we're talking about absolute value, as we said, it's the distance from 0 on a number line. Now, distance is always positive. We can't talk about a negative distance. There are ways to talk about negative movement, but when we think of distance, distance is always positive because it's just an amount of space traveled between two places. It doesn't have a direction. So even though 5 and negative 5 are in different directions on the number line, there's still a distance of 5 units away from 0. And another way to look at that is to look at a map. And here we're going to look at Cincinnati, which is a city in the southwestern part of Ohio, because Cincinnati is a great place to look for things like that. Even though they're not the exact distance, we can see that Cincinnati is about the same distance from Columbus. Let's turn that to a different color. From Columbus, from Indianapolis, and from Lexington. So again, they're not exactly the same distance from each other, but they're all about the same. And they're not all in the same direction away from Cincinnati. But if we asked someone what's the distance between Cincinnati and Indianapolis, or Cincinnati and Columbus, or Cincinnati and Lexington, they would give us about the same values, because they're all about the same distance away, even though they're in different orders. And that's really what we're talking about with absolute value. To represent that we want to know what that distance is, we use these vertical bars. And so here, where I'm circling a 5 in the vertical bar, that means the absolute value of 5, or the distance from 5 away from 0 on a number line. And that distance is 5. When we have negative 5 in the absolute value bars, we read that the absolute value of negative 5, and it's still just asking about the distance of negative 5 from 0 on the number line, which is also 5. Again, because distance is always positive. And so we can use that idea that that's what it means to find the absolute value of a few different numbers. Now, fractions and decimals just represent numbers on a number line, much like integers do. So we can find absolute values of these types of things. I'm going to walk us through these problems, and then we'll have one more slide that has the problems for you to calculate. So this first problem over here, which I'll label number 1, is asking us how far is 1 3500ths from 0 on a number line. And like all positive numbers, the number itself just gives us the distance. It is 1.35 units away from 0 on a number line. So the absolute value of 1 3500ths is just 1 3500ths. Now for the second one over here on the right with negative 7/12, we're asking how far away is negative 7/12 from 0 on a number line. Well, since the number line acts like a mirror, negative 7/12 is the same distance away from 0 as 7/12. So the absolute value of this negative number is just its positive equivalent, because that's how far negative 7/12 is from 0 on a number line. We're going to go down now, and not down to the left, but just down for number 3. It's the same kind of idea. Negative 18 is the same distance as 18 away from 0 on a number line. So the absolute value of negative 18 is just 18. And for the fourth one here, we notice our negative sign is outside the absolute values. And in this case, it's not a negative. It means opposite, which is one of the confusing things about a negative sign, is that it can mean a lot of different things: subtraction, opposite, and negative. So this is asking for the opposite of the absolute value of 12. Well, 12 is a distance of 12 away from 0 on a number line, and the opposite of 12 is negative 12. So the opposite of the absolute value of 12 is just negative 12. So take what we've seen here, what we've learned so far in the video, pause the video, and find the absolute value of these 8 example problems. Pause the video and come back when you are ready to go through them. So for number 1, we want to know how far 215 is from 0 on a number line. And for all positive numbers, the number itself gives us that distance. So it is 215. For number 2, we're going to recognize that the negative sign is actually outside the absolute value, so it's an opposite. The absolute value of 27 is 27, because it's a distance of 27 away from the number line. And we're asking for the opposite of that, so our answer is negative 27. This opposite sign doesn't get erased by the absolute value, like we can think about it, because it's outside, where it's the opposite of that distance. For number 3, negative 1/2 is just a distance of 1/2, because a positive and a negative number that have the same numerical value, that have the same, that would be the same if we removed the negative sign, have the same absolute value. Opposite numbers have the same absolute values. In 4, negative 5.04 is the same distance away from 0 as 5.04. So that's the absolute value we're looking for there. The same with negative 215 is the same distance away as positive 215, which is why we put it right under that there. So we can see that a positive and a negative number have the same absolute value if their numerical value looks the same. The absolute value is 77. That's 77 units away from 0 on a number line. The opposite of the absolute value of 8 is 8 units away from 0 on a number line, so this is negative 8. And 0 is itself, so it doesn't have a distance away from itself on a number line, so the absolute value of 0 is 0. So one more time, the absolute value just represents the distance from 0 on a number line, and we represent absolute values by using these vertical bars. If a number is inside the vertical bars, it's asking for the distance from 0, or the distance of that number away from 0 on a number line. But if you notice the negative sign outside the bars, then we're looking for the opposite of that absolute value.